The last thing out of this that we want to talk about are transformations. Okay, so given any kind of generic function here, I'm just going to go with variables. This is the same ones that are in your book here, so just generic variables, and we'll talk about what they all mean. C times f of a times x minus b plus d. That's a d. Try again. All right. Let's talk about what all this stuff is. First of all, this is my f of x function, right? That is my f of x function. All of the stuff around it are transformations. That f of x, that is my function. A, B, C, and D, those are the transformations. Okay, so let's lay out what we've got going for us here. If I have vertical, change my colors here, vertical coming at you, vertical is always outside of my function. So outside of that f of x part, that's all vertical. Inside those parentheses at f of x, that's horizontal. All right? Okay. So this C being outside of that f of x part, that talks about vertical. And if it's multiplied, do you guys remember what that is? Stretching and shrinking, good. This is vertical, stretch, and shrink. That's what that is. If this is negative, remember how I said we were going to see if it goes all the way up for the polynomials or down? If it's negative, that's that reflection. Negative is a vertical reflection. Okay. And again, with the vertical, if I'm coming back here outside of my function, this is going to be a vertical shift. It's a shift because it's added and subtracted to it. Stretching and shrinking is multiplied. Added or subtracted, if I'm looking at it, that's a shift. And because it's vertical, that tells me it's going to go up or down. All right? Okay, that's my vertical transformations. Now let's focus on the inside here. Again, this A is multiplied. If it's multiplied, that's that stretching and shrinking. That's my stretching and shrinking that's multiplied. And again, if this is negative, then it's a horizontal reflection. Okay, so anytime I'm multiplying with the stretching and shrinking, when it's negative, that's what makes my reflection. Now this B here, this one is subtracted, but it's that same kind of thing, right? If I am adding or subtracting, that makes a shift. So this is going to be my horizontal shift, which is that movement. Pick the whole thing up and move it. That's what a shift is, going left or right, because it's horizontal, right? The vertical shifting goes up and down. Horizontal shifting is left or right. Now here's the key, y'all. Anything that is horizontal is always going to be opposite of what you think. Ooh, of what you think it should be. Let me write that. Because if you know what it is, then what you think is what it is. When I have a big number here, you think, oh, a big number means stretch it out, make it bigger. Nope. A big number is a shrink. A big number out here is a stretch. Vertical is exactly what you think it's going to be. What you intuitively feel like is going to happen, that's vertical. Positive goes up, negative goes down. See this minus sign right here? That's what makes it opposite. If this is minus b, it's going to go to the right. If it's plus some value, that's going to go to the left because it would be minus and negative, right? Vertical is exactly what you intuitively think is going to happen there. Horizontal is opposite. All right? Try this on. What if I have something like, oh, I don't know, let me make this where we can still see it. Example, smiley face. What if I have y is equal to the absolute value of x minus 2, right? You have your original f of x is equal to the absolute value of x, right? That's the parent function, it's called most of the time, or the original function, or the origin. I mean, I don't know. Can't remember what my math lab calls it, but its parent function is the typical thing it's called. So inside the absolute value, so is that going to be horizontal or vertical? Horizontal, good. And this says minus 2. Remember what we know about horizontal? So what is this? Right 2, good job. Even though it's minus here that I'm looking at, it's going to go to the right 2 because my formula is a minus and I know horizontal is opposite of what we think. Okay, let's do this other one here. Here's actually example 9. I have f of x is equal to the absolute value here of 2x plus 1. Now here's the kicker on these problems. When you have that coefficient, notice your formula. This is factored out. Your a value is actually factored out, leaving your b value inside the parentheses. If you have something like this, you have to factor that first. So this is actually f of x is equal to the absolute value of 2 times x plus 1/2. Do you see what just happened? Now, oops, I have an a, which is factored out, and I have a b, which is inside those parentheses. You cannot take this for an a and a b because it's not set up the same way as our formula dictates. Yes, good. Make sure you factor that out. Now, I'm looking at this a, and remember anything horizontal is opposite of what you think. So it's going to be a horizontal shrink. Good. By a factor of, it talks about that sometimes, by a factor of 2. All right, that's your horizontal shrink. And then, how am I shifting horizontal? Remember, it's plus, but it's opposite of what we think. To the left 1/2. Good. Left 1/2. All right. Anything vertical is straight up what you think it's going to be. Horizontal is opposite. Okay, good. Yeah, kicking back to those transformations. Transformations are super good general knowledge whenever it comes to any kind of function out there ever. It doesn't have to be a absolute value. It could be a polynomial. It could be anything. If it's set up like this, you could use those transformations and get good working general knowledge. I can't impress that enough. Good working general knowledge. Basics of graph.